Dear student, welcome to the second part of application of partial differentiation of engineering mathematics 1. In this part, we will discuss jacobian of three function. Okay, let's see the example of jacobian of three function. Okay, in this question, we have to given that x is equals to r sin theta cos phi, y is equals to r sin theta sin phi, and z is equals to r cos theta. Okay, then we have to show that del x comma y comma z upon del of r comma theta comma phi, which is equals to r square upon sin theta. Okay, now see how to solve this type of example. Firstly, right here given information means that given that we have to given three functions x, y, and z simultaneously. Now, we have to know we have to given that prove that we have to prove that or show that in the question we have to use LHS or RHS. Okay, I will I'm taking here a left hand side which is equals to del x comma y comma z upon del of r comma theta comma phi. It means that this is the jacobian, we denoted by jacobian is equals to j. Okay, then convert this jacobian in the form of determinant. Okay, okay, here is a three function and three variable, that's why your jacobian is in the form of 3 by 3 order. Okay, in this first row I am write here del x upon del r, del x upon del theta, del x upon del phi, and in the second row del y upon del r, del y upon del theta, del y upon del phi, and the third row del z upon del r, del z upon del theta, and del z upon del phi. Okay, in this meaning of this all the terms, it means that we have to see here del phi by del r. It means that partial derivative of x with respect to r. Okay, what is x? X is here r into sin theta into cos theta. Okay, what is the derivative of x with respect to r? Okay, here only r and remaining two terms in the form of multiplication, that's why derivative of r is 1 into this term is sin theta into cos phi. Okay, so I am right here sin theta into cos phi. Next term, derivative of x with respect to theta, it means that derivative of sin theta. Okay, derivative of sin theta is a cos theta, so I am right here r as it is cos theta into cos phi as it is. Okay, now next term is del phi upon del x upon del phi. What is in the phi derivative of cos phi is a minus sin phi, then I am right here minus r into sin theta into sin phi. Okay, next row we have to find del y by del r. It means that partial differentiation of y with respect to r. Okay, with respect to r, it means that our derivative of r is 1 into remaining two term is as it is sin theta into sin phi. Next, del y by del theta means partial derivative with respect to theta. Derivative of sin theta is a cos theta, so r into cos theta and sin phi as it is. Okay, next row del y by del phi means partial derivative of y with respect to theta, sorry, with respect to phi. It means that r into sin theta and cos phi. Okay, last similarly find the last row means del z by del r. Okay, derivative of z with respect to r means cos theta as it is, and derivative of z with respect to theta, it means r into derivative of cos theta is a minus of sin theta, and derivative of z with respect to phi is 0 because there is no term in terms of phi, that's why derivative of this term is 0. Okay, now look at this determinant in the determinant is 3 by 3 order, or and we have to know everyone how to solve this determinant. Okay, now see the how to solve this determinant. Look at here. Okay, first time is Sine theta into cos theta, sorry, sine theta into cos phi in bracket remaining, uh, this term, this row, sorry, this column and this row is cross of remaining two, remaining multiplication and subtraction of these four terms. This term into this term is 0, because 0 into anything 0. Then multiply this minus into, okay, this term is minus and minus 0, minus or minus this term plus. R into R is R square, sin theta into sin theta is a sin square theta, and cos phi as it is. Okay, first bracket close. Then second, minus of R cos theta into cos phi in bracket. Now first row and second column is cross up, then remaining element multiplication and then subtract it. Sin theta into cos phi into 0, this into this 0, minus r sin theta into cos phi into cos theta. So I am right here r into sin theta cos phi cos theta, second bracket close. Okay, then next, minus of r into, sorry, minus r into sin theta into sin phi in bracket. Okay, now first row and sorry, first row and third column cross off and remain multiplication of remaining these four element. Sin theta into sin phi into r minus of r sin theta. So minus r sin theta into sin theta, sin square theta, sin phi, and okay, then minus this multiplication of these two terms, r into cos phi into cos theta. Okay, so sin phi into cos theta into cos phi. Okay, now simplification of this bracket. Okay, look at this, sin theta into cos theta into this sin theta into cos phi is multiply this whole bracket. So I am right here r square into sin square theta into sin theta is a sin cube theta, cos phi into cos phi is a cos square phi. Okay, this bracket is done. Now look at here this term, minus into minus plus. So I am right here r into r is r square, cos theta into this cos theta, cos square theta. Okay, cos phi into this cos phi, cos square phi, and remaining this sin theta is as it is sin theta. Now next term is this minus into this minus is plus, r into r is r square, sin theta into sin square theta is a sin cube theta, sin phi into sin phi into sin phi, sin this sin phi into this sin phi, sin square phi. Then this minus into this minus is plus, r into r is r into r is r square, sin theta into sin phi. Okay, sin theta sin phi and cos theta cos phi, remaining terms as it is. Okay, bracket close. Next, look at here, look at this, all the terms r square r square r square and r square. I am taking r square common with, here is a sin cube theta, here is a sin theta, here is sin square theta, here sin theta. So I am taking also sin theta is a common, so writing remaining terms here, r square theta into sin is common, that remaining is sin square theta into cos square phi. Okay, this is not theta, this is a phi, plus here is remaining term only, cos square theta into cos square phi. Okay, next term, there is only present sin square theta into sin square phi, and remaining terms is sin phi and cos phi into cos theta. Okay, look at here, sin square into sin r square into sin theta is as it is. Okay, look at this whole term. Okay, I am taking common from these two terms, I am taking from this these two terms taking common, cos square phi, and remaining is sin square theta into, sorry, sin square theta into, sorry, plus cos square theta, and remaining these two terms is into what we taking common, cos square phi, sorry, sin square phi, taking sin square phi, then remaining is sin square theta plus cos square theta. Okay, we know that sin square theta plus cos square theta is equals to 1. That's why I am writing here cos square phi as it is into this term is 1 plus sin square phi into this term is 1. Okay, same r square into sin theta, I am right here cos square phi into 1 is a cos square phi plus sin square phi into 1 is a sin square phi. So again use this trigonometric identity, here only theta but here phi in notation parameter is a phi. So I'm right here r square into sin theta into the meaning of this term is 1 into r square into sin theta is again r square into sin theta, which is equals to RHS. Okay, thank you student.